Good evening, everyone. My name is Claudio, and I'm here to present the paper that is entitled High Performance Moves Recognition and Sequence Segmentation Based on Key Pose Filtering. Our work has a focus on sports due to the importance that sports have in our society. Here in Lake Placid, we can see a good example since the city has hosted more than one Winter Olympic Games. And we aim to help athletes by analyzing their training sessions. To accomplish our objective, we develop a methodology to assist athletes to improve their performance by recording a training sequence and automatically recognizing and segmenting their training sessions. Our strategy is to select just a small number of frames composed of discriminative poses, the key poses, and use the LDCRF, the latent dynamic conditional random field, to predict the label of each frame of the training sequence. Our methodology is composed of three steps. The first one is the key pose extraction, where we assign a key pose to each frame of the recording. The second one is the key poses filtering, where we select just a small number of frames, just a small number of key poses that were previously extracted. And the third one is the LDCRF training and testing. We experimented our methodology in the Taekwondo Olympic sport. We selected 10 high-performance athletes performing 7 moves. And we compared our methodology that uses LDCRF and key poses filtering with the LDCRF using all frames of the recording, and comparing also with the decision forest with both data sets. Here we have some examples of moves and their corresponding key poses. Here we have the results we achieved using our methodology of 74.72 average accuracy. There's a much better result than using the LDCRF and all frames of the recording. We also had a very better result than using decision forest in both data sets. Concerning running time, we also had a very good performance since we used 7 times less processing time. The confusion matrix of our approach also shows the very good performance we had in the moves individually. We can highlight here the right punch, the punch moves, the right kicks, and we can also notice here a performance degradation in the left kicks due to the bigger body rotation they have. Here we can see a segmentation chart comparison between our methodology and the decision forest. We can see here that our methodology returns a more smooth and accurate temporal segmentation chart, while in the decision forest we cannot see properly where are the moves transitions. The contributions of our work is that we develop a completely new framework for high performance moves that is generic enough not only to use in Taekwondo but other Olympic sports. One highlight of our research is that we focus on fast moves. Another contribution is that we showed that using just a small number of frames of the recording yields better results than using all frames in this kind of challenging scenario of fast moves. Another important contribution is the data set we compiled, composed of high performance moves, high frequency moves, that is available to the community for further experiments. In our data set we have a 3D body joint information combined with body joint angles.